A light year sounds like time, but it is actually distance, and this is where the confusion begins. When people hear the word year, they think about days, months, birthdays, and waiting for things to happen, but a light year has nothing to do with waiting. A light year is how far light travels in 1 year, and light is the fastest thing in the entire universe. Nothing we know can go faster. Light moves so fast that if it went around Earth, it could circle the planet more than 7 times in just 1 second. Now, imagine letting that speed run nonstop for a full year, day and night, without slowing down even a tiny bit. The distance it covers is 1 light year, and that distance is so massive that our brains were never built to truly feel it. To understand why this breaks your brain, think about how humans understand distance in daily life. We understand steps, rooms, streets, and maybe cities. A long trip for us might be a few hours in a car or a long flight across a country. Even the biggest distances we deal with still fit inside Earth. But space does not care about Earth-sized thinking. Space laughs at it. Space uses distances so large that numbers stop feeling real and turn into empty words. A light year is about 9 trillion kilometers, but saying that number does not help because your brain cannot imagine a trillion of anything. You cannot imagine a trillion grains of sand, a trillion seconds, or a trillion ants, so expecting your brain to imagine a trillion kilometers is already a losing game. Here is a simple example to show how fast light really is. If you turn on a flashlight and point at the moon, the light reaches the moon in about 1 second. That feels instant to us. Now imagine pointing that same flashlight at the sun. The light takes about 8 minutes to reach it. That means when you see the sun, you're actually seeing it as it was 8 minutes ago. If the sun suddenly disappeared, which is not going to happen, we would not know for 8 whole minutes. That alone is already strange, but now comes the wild part. The nearest star after the sun is so far away that its light takes more than 4 years to reach us. That distance is just over 4 light years. This means when you look at that star, you're seeing it as it was 4 years ago, like watching an old recording from the past. Now pause and think about this slowly. The nearest star is not 10 light years away, not 100, but more than 4 light years, and that is considered extremely close in space. That is like saying the nearest grain of sand is 4 kilometers away. If space were a city, stars would not be houses next to each other. They would be cities separated by oceans of nothing. This is why scientists use light years instead of kilometers or miles. Normal units collapse under the weight of space. They become useless. Light years are not chosen to sound cool. They are chosen because without them, space distances would be unreadable walls of zeros. Let's make this even more real. Imagine shrinking the entire universe so that the sun is the size of a small orange. In that model, Earth would be a tiny grain of sand a few meters away. The nearest star would not be in the same room, not in the same building, but thousands of kilometers away in another country. And that is just 1 light year scale. When people hear that a galaxy is 100,000 light years wide, they nod their heads like they understand, but they do not. If 1 light year already stretches your brain, 100,000 light years completely snaps it. Your brain simply gives up and says, okay, sure, without truly feeling anything. The Milky Way galaxy, the place we live in, is about 100,000 light years across. That means light, moving at the fastest speed possible, takes 100,000 years just to cross it from one side to the other. Humans have not even been around for that long. Civilization itself is only a few thousand years old. So when you look up at the sky, you're not just seeing faraway places. You're seeing deep time. You're looking at light that started its journey before cities existed, before writing existed, before humans understood what they were. And here's the part that really messes with your head. Some of the stars you see in the night sky might not even exist anymore. They could have exploded or collapsed thousands or millions of years ago, but their light is still traveling toward us, like a message sent long ago that is only now being received. Space is full of these delayed messages. Every point of light is a story from the past, and light years are the timeline those stories travel on. This is why people say light years are so big that your brain cannot understand them. It is not an insult to intelligence. It is simply a fact about human evolution. Our brains evolved to survive on the African savanna, to judge the distance to a tree or a running animal, not to understand distances that take light years to cross. When we try, our brains use tricks, comparisons, and metaphors because direct understanding is impossible. We're stretching a small tool to measure something enormous. And this is only the beginning. We have not even left our galaxy yet. Outside the Milky Way, distances stop being thousands of light years and start becoming millions and billions. Galaxies themselves are separated by spaces so large that even light feels slow. Once you step into that scale, light years no longer feel big enough, and scientists start using millions of light years as casually as we use kilometers. At that point, the universe is not just big, it is emotionally overwhelming. One of the strangest things about light years is that distance and time become the same thing. On Earth, distance and time are separate ideas. You ask how far something is, then you ask how long it takes to get there. In space, those questions merge into one. When something is 1 light year away, you are also saying it is 1 year in the past. That means the universe forces you to think about distance as history. Every time you look far enough into space, you are not looking at where things are now, but where they were long ago. Your eyes become time machines without you even noticing. Imagine standing in a giant dark field at night, surrounded by people holding lanterns. Some are close, some are far. The closer ones reach your eyes instantly. The far ones take longer for their light to reach you. Now, imagine some lanterns are so far away that the person holding them has already left, but the light is still traveling. You're seeing a moment that no longer exists. That is exactly what space is like, except the distances are not meters or kilometers, they're light years. This means the universe is layered like an onion of time, with each layer showing a different age. Let's use a very simple example. If a star is 10 light years away, the light you see tonight left that star 10 years ago. That means if aliens lived on a planet around that star and looked at Earth with a powerful telescope, they would see Earth as it was 10 years ago. They would not see what you are doing now. They would see old news. In a way, the universe is full of delayed conversations, where everyone is always talking to the past. No one ever sees the present of distant places. Now, take this idea and push it further. Some galaxies we observe are millions of light years away. That means we're seeing them as they were millions of years ago. Some are billions of light years away, meaning their light started traveling before Earth even existed, before oceans, before life, before anything we recognize. When you hear that, your brain tries to hold on to it, but it slips away. The numbers become too big, the time too deep. It is like trying to imagine infinity. You can say the word, but you cannot truly feel it. This leads to a strange truth. There is no single now in the universe. What is happening right now on Earth is not happening right now everywhere else in the same way. The farther you go, the more now breaks apart. Light years stretch reality itself. This is not science fiction. This is how the universe actually works. The speed of light sets a hard limit on how fast information can travel, and because of that, distance becomes delay. Here is another example to make it hit harder. Imagine the Earth suddenly sent a giant bright signal into space, like turning on the brightest flashlight ever made. That signal would not instantly tell the universe that Earth exists. It would slowly expand outward at the speed of light. After 1 year, only stars within 1 light year would know. After 1,000 years, stars within 1,000 light years would know. Right now, that signal would still not have reached most of our own galaxy. The Milky Way is so huge that Earth's existence is still unknown to the vast majority of it. That is how small we are on a light-year scale. People often ask why space feels empty and lonely. Light years are the reason. Everything is so far apart that even the fastest thing in existence needs years, centuries, or millions of years to cross the gaps. Space is not crowded. It is mostly nothing. If the universe were a city, It would be a city where buildings are separated by thousands of kilometers of empty land. That emptiness is not just space. It is time, stretched out and frozen into distance. Now let's talk about speed, because this is where humans really struggle. We think airplanes are fast. A jet can fly around the Earth in about 2 days. That feels impressive. But at that speed, reaching the nearest star would take tens of thousands of years. Even our fastest spacecraft would need over 70,000 years to travel just 4 light years. Entire civilizations could rise and fall in that time. Languages would change. Species could evolve. And the spacecraft would still be traveling, slowly crawling across a tiny part of space. This is why science fiction often talks about faster-than-light travel. Without it, the universe is basically locked away from us. Light years are like giant walls, not because they block movement, but because they demand time. You cannot cheat them. You must pay the full cost in years. And humans, with lifespans of decades, are not built for journeys that take thousands or millions of years. Light years expose a hard truth about our limits. Another interesting way to feel this is to think about messages instead of travel. If we sent a radio message to a star 10 light years away and asked, "Is anyone there?" the earliest possible reply would come 20 years later. 10 years for the message to go, 10 years for the reply to return. That is if someone is already listening and answers immediately. Most conversations would take longer than a human lifetime. On a light-year scale, patience stops being a virtue and becomes a requirement. And remember, all of this is still local. We're still talking about nearby stars and our own galaxy. Once we leave the Milky Way, light years stack on top of light years until the numbers become absurd. The nearest large galaxy is millions of light years away. Light that left there when early humans were just learning to use tools is only reaching us now. The universe you see is a museum of ancient light, and light years are the labels telling you how old each exhibit is. This is why light years do not just measure space. They measure perspective. They remind us that the universe does not care about our sense of scale, our sense of time, or our sense of importance. Light years shrink us emotionally. They make Earth feel fragile and brief. And yet, at the same time, they connect us to everything because every atom, every star, every galaxy is linked by the same light, traveling endlessly through the dark. At some point, light years stop doing their job. They're supposed to help us understand distance, but instead they begin to blur together. When everything is measured in thousands or millions of light years, the numbers lose their emotional impact. Saying something is 1 million light years away sounds impressive, but your brain reacts the same way it reacts to hearing 100 million or 1 billion. It just shrugs. This is not because you are bad at understanding. It is because the scale is so far beyond human experience that all those numbers live in the same mental box labeled too big. Let's talk about galaxies. A galaxy is a massive system of stars, gas, dust, and dark matter, all held together by gravity. Our home, the Milky Way, contains hundreds of billions of stars. Just saying that number already pushes the limits of imagination, but what matters here is size. The Milky Way is about 100,000 light years wide. That means if light started at one edge of our galaxy, it would need 100,000 years to reach the other side. Dinosaurs lived and died in much shorter time spans than that. Human history fits inside a tiny fraction of that distance. Now here's something that really messes with people. Even though the Milky Way is huge, it is not special. It is just one galaxy among hundreds of billions of others. Each of those galaxies is separated by millions of light years of mostly empty space. Imagine a beach where each grain of sand is a galaxy. The grains are close together compared to space, but now imagine stretching that beach until each grain is separated by kilometers. That is closer to how the universe actually looks. The nearest large galaxy to us is the Andromeda Galaxy. It is about 2.5 million light years away. That number alone is hard to hold on to, but here is the interesting part. Andromeda is moving toward us. It will collide with the Milky Way in about 4 billion years. When people hear collision, They imagine stars smashing into each other. But space is so empty that most stars will pass by without touching anything. The galaxies will slowly merge over hundreds of millions of years. Light years make even collisions slow and graceful. Here is a simple comparison. If the Milky Way were the size of a dinner plate, Andromeda would be another dinner plate several meters away. Everything between them would be air. Not walls, not dust, just empty space. And yet, even across that emptiness, gravity works patiently, pulling them together over billions of years. Light years are the stage where gravity performs its slow dance. Now let's go even bigger. Galaxy clusters are groups of galaxies held together by gravity. These clusters can contain thousands of galaxies, all orbiting each other across distances measured in millions of light years. And then there are superclusters, massive structures made of many galaxy clusters. These are some of the largest structures in the universe, stretching across hundreds of millions of light years. At this scale, words like far stop making sense. There is no everyday comparison that truly fits. Scientists have mapped the universe on these scales, and what they found is shocking. Galaxies are not spread evenly. They form long filaments and walls, with huge empty regions in between called voids. Some of these voids are hundreds of millions of light years across, containing almost nothing. Imagine a bubble so large that light needs hundreds of millions of years to cross it, and inside that bubble, there are almost no galaxies at all. This emptiness is real. The universe is not just big. It is mostly empty on a scale that makes emptiness itself feel enormous. Here is a fun but terrifying thought. If you were somehow placed in the middle of one of these cosmic voids, there would be no visible galaxies in any direction, even with powerful eyes. The night sky would be almost completely dark. You would have no clue where you were or how far you would need to travel to reach anything. Light years would stretch endlessly around you, and the universe would feel silent and abandoned. This is what most of the universe actually looks like. Now, think about this. When astronomers look deep into space with powerful telescopes, they're not just looking far away. They're looking back in time toward the early universe. The farther they look, the younger the universe appears. At extreme distances, they see galaxies forming, stars being born, and structures that no longer exist nearby. Light years allow us to do something impossible in everyday life: observe history directly. Some of the most distant light we can see comes from a time when the universe was very young. That light has been traveling for over 13 billion years. It started its journey when the universe was a fraction of its current age. That means the universe itself is larger than 13 billion light years across, because space has been expanding while the light traveled. This is where numbers stop behaving intuitively. Space grows while light moves through it. Distance stretches over time. Even light years cannot fully capture this. This is why scientists sometimes say the observable universe has a radius of over 40 billion light years. That number sounds impossible if the universe is only about 13 billion years old, but expansion changes everything. Space itself stretches, carrying galaxies with it. Light years are no longer just rulers. They are part of moving, growing cosmic fabric. At this point, it becomes clear why your brain struggles. Light years are not just large distances. They represent a universe that does not sit still, does not scale down nicely, and does not care about human intuition. Everything is bigger, older, slower, and farther than we feel comfortable with. Light years expose the fact that reality is not designed to be easily understood. And yet, there's something beautiful about this. Even across millions or billions of light years, light still reaches us. The universe, no matter how big, is not completely hidden. It sends us signals patiently, one photon at a time. Light years are the threads connecting us to everything else, no matter how distant. Light years do something strange to the human mind. At first, they feel exciting, like a big adventure. Then they feel confusing. And finally, they feel humbling. When people truly start to grasp how big a light year is, even just a little bit, it changes how they see themselves. Not in a scary way, but in a quiet, deep way. Light years shrink egos. They turn loud thoughts into whispers. They remind us that we are living on a tiny island of matter floating in an ocean so large that even light struggles to cross it. Let's try an everyday comparison that hits emotionally. Imagine your entire life, from the day you were born until the day you die, fits into 1 second. Now, imagine the age of human civilization is 1 minute. The time it takes light to cross the Milky Way would be more than a full day. And the age of the universe would stretch into years. When you place yourself on that timeline, you realize how brief your moment is. Not meaningless, but brief. Light years turn time into something fragile and precious. Now, think about travel again, but in human terms. If you boarded a spaceship traveling at the speed of light today and went on a journey of 10,000 light years, you would arrive 10,000 years in the future relative to Earth. Everyone you ever knew would be gone. Every culture, language, and nation would have changed or disappeared. Even the planet itself might look different. Light years are not just distances you cross. They are lives you leave behind. This is why space travel feels romantic and tragic at the same time. The farther you go, the more disconnected you become from your own story. Light years force you to accept separation as the cost of exploration. There is no fast visit. There is no quick return. Space is honest about that. It does not offer shortcuts. It demands time. Here is another example that really sticks with people. When astronomers discover a planet around a star 1,000 light years away, they are not discovering something new in the present moment. They are discovering something that existed 1,000 years ago. That planet could already be gone. Its star could have changed. Its surface could be completely different. Discovery in space is always delayed. Light years mean that certainty is rare and patience is mandatory. Light years also change how we think about danger. When a star explodes in a distant galaxy, that explosion might be powerful beyond imagination, but if it is millions of light years away, it is harmless to us. The danger fades with distance, not because the explosion is weak, but because space is vast. Light years act like a cosmic safety buffer. The universe can be violent, but the distances soften the impact. At the same time, light years make help impossible. If Earth were in trouble and we needed help from another star system, no rescue would arrive in time. Even sending a warning would take years. This is why Earth feels isolated. Not alone in the universe, but isolated by distance. Light years are the reason we must solve our own problems. No one is coming quickly from across the stars. This realization can feel heavy, but it can also feel empowering. If this tiny planet is all we have for now, then it matters more, not less. Light years do not make life meaningless. They make it rare. In a universe so big and so empty, a planet full of life becomes something special, something worth protecting. There's also something poetic about how light years connect everything. The atoms in your body were once inside stars. Those stars exploded long ago, and their light and matter traveled across space for millions or billions of years before becoming part of Earth. In a very real sense, you are made of ancient light. Light years are written into your existence. You are not separate from the universe. You're a product of it. People often ask why thinking about space makes them feel calm or emotional. Light years are the reason. They pull your thoughts away from small worries and place them against something vast. Problems do not disappear, but they shrink into perspective. When you compare a bad day to billions of light years of cosmic history, it loses some of its power. Here is one last image to hold on to. Imagine every thought you have ever had is a spark of light. Now, imagine those sparks trying to cross the universe. Most would never reach anywhere else. They would fade into the dark. And yet, the fact that any light reaches anywhere at all is incredible. Light years remind us that connection, even delayed and distant, is possible. Light years are not just big numbers. They are mind-bending tools that turn intuition upside down. Humans are wired to understand small distances, like how far a car can go in an hour or how many steps it takes to reach a store. But when distances become light years, our brains fail to keep up. Even trying to imagine a single light year is almost impossible. Now imagine millions or billions of light years. Your mind wants to shrink the numbers, but the universe refuses. There is no shortcut. There is no metaphor big enough to contain them. A simple thought experiment can show why. Imagine shrinking the entire solar system so that the sun is a single marble. Earth would be a tiny speck orbiting around it, smaller than a grain of sand. Now shrink the nearest star, Proxima Centauri, the closest to our sun, to marble size. Even at that scale, the distance between these marbles would be more than 4 kilometers. That is a city apart, and that is just 1 light year. Now multiply that distance by hundreds of thousands for the Milky Way and by millions for other galaxies. No city, no map, no human comparison can make that feel real. Your mind collapses under it. Here is another mind twist. If light takes over 4 years to reach the nearest star, then every signal we send to that star is already out of date. By the time it arrives, everything might have changed there. Imagine sending a letter to a friend who lives 4 light years away and only getting a reply 4 years later. Every conversation takes 8 years. Humans cannot relate to that kind of delay. We expect instant replies, instant communication. Space ignores our expectations. Light years enforce patience on a cosmic scale. Now think about speed. Even our fastest spacecraft are crawling compared to light. The Parker Solar Probe, one of the fastest human-made objects ever, can travel at about 700,000 kilometers per hour. That sounds fast, but at that speed, reaching Proxima Centauri would take thousands of years. Light years are so vast that even extreme speed becomes painfully slow. It turns our concepts of fast completely upside down. Let's add another layer, the expansion of space. Galaxies are not stationary. The universe is stretching. Some galaxies are moving away from us faster than light because space itself is expanding. Wait, faster than light? Isn't that impossible? Not quite. Nothing can move through space faster than light, but space itself can expand at any speed. That means some parts of the universe are already unreachable. Their light will never reach us. Light years stop being a simple ruler and start being a rulebook of possibility. Some places are permanently out of reach. Here is a mind-bending comparison. The observable universe is about 93 billion light years across. That means light has traveled over 13 billion years to reach us. But because space expanded during that time, the actual distances are far larger. Numbers like 93 billion are so big they lose meaning. Trying to picture them is like trying to imagine infinity. We can say the words, but the brain cannot hold them. Even closer to home, the scale of our galaxy is astonishing. There are hundreds of billions of stars in the Milky Way alone. If each star were a note in a song, the galaxy would play a symphony so long it would take 100,000 years to finish. And that's just one galaxy. Multiply by billions of galaxies, and you enter the realm of the incomprehensible. Light years are the beats of that cosmic symphony. They're the measure of music that plays across time and space. Finally, here's one of the most mind-bending things, gravitational lensing. When a massive object like a galaxy cluster bends light, it allows us to see objects that are otherwise behind it, farther away than we thought possible. That light has traveled billions of light years, and yet we can still see it today. Light years are not just distances. They're stories traveling across the universe. Every beam of light is a journey, a history, a message from a place and time that no human will ever visit. Light years stretch reality itself. They remind us that our intuition, our daily experience, our sense of scale, all fail at cosmic distances. But they also connect us to a universe so vast and beautiful that being small suddenly feels like a privilege. We get to witness it. We get to measure it. We get to imagine it. And even if our brains cannot fully understand it, we can still feel awe. Light years were not always part of human thinking. For centuries, humans measured the world in steps, miles, or days of travel. Distances beyond Earth were almost impossible to imagine. People looked at stars and thought of them as tiny points of light, close enough to be part of our world, like lanterns in the night. No one could grasp the true scale. Then, over time, scientists discovered that the universe is unimaginably vast, and they needed a new unit of measure. That is how the light year was born. The first step was realizing that light has a speed. For thousands of years, philosophers and scientists wondered if light traveled instantly or if it moved. In 1676, a Danish astronomer named Ole Romer made a breakthrough. He studied the motion of Jupiter's moons and noticed that the times they appeared to orbit changed slightly, depending on Earth's distance from Jupiter. From this, he deduced that light must have a finite speed. Light does not travel infinitely fast. This was revolutionary. Suddenly, humans could start measuring distance by time, how long light takes to travel. Once the speed of light was known, calculating a light year became possible. A light year is how far light travels in 1 year, which is roughly 9.46 trillion kilometers. That number is so large, it is almost meaningless on its own, but it became a critical tool for understanding space. Astronomers could now say, this star is 4 light years away, and know exactly how far its light had traveled to reach Earth. Suddenly, the universe went from being an infinite blur to something measurable, even if still impossible to fully imagine. Here is a simple analogy to make it easier. Imagine a super fast car that can drive around the entire Earth 7 times in 1 second. Now, imagine leaving that car running nonstop for 1 year. The distance it covers in that year is 1 light year. It is like a cosmic race car moving faster than anything else in the universe. Thinking in terms of this car helps the brain picture light years, even if only roughly. Another example is to think about steps. The average human step is about 1 meter. To walk 1 light year, you would need to take about 10 trillion steps. If you walked 1 step per second without stopping, it would take hundreds of thousands of years to finish. This analogy shows how tiny human scales are compared to cosmic scales. A single light year dwarfs a lifetime of walking. Let's put light years in terms of our solar system. The Sun is about 8 light minutes from Earth. That is small in cosmic terms. The nearest star, Proxima Centauri, is more than 4 light years away. That is 270,000 times farther than the Sun. The planets, asteroids, and moons in our solar system are just tiny ripples in the pond compared to interstellar distances. Light years show that space is mostly empty. Distances between stars are like islands in a vast ocean. Humans gradually learned to map the stars using light years. In the 19th and 20th centuries, astronomers measured hundreds of stars, then thousands, then millions. Telescopes became more powerful, and we could see galaxies millions or billions of light years away. Each measurement was a glimpse into the past. Every new light year calculated was a new story from the universe's history. Light years turn the night sky into a timeline, allowing humans to see both distance and time at once. Here is an engaging example for audiences. Imagine sending a message to the nearest star. If you could send a super fast email at the speed of light, it would arrive in more than 4 years. Then imagine sending a message to the Andromeda Galaxy, 2.5 million light years away. Even if you started today, your great-great-great-great-grandchildren would be long gone before it arrived. Light years put communication into a scale humans cannot experience directly. Yet despite this, light years also connect us emotionally. They allow us to understand that the universe has a story and we are part of it. Every star we see is a messenger from the past. Every beam of light traveling billions of light years is a cosmic postcard arriving today. Light years are more than numbers. They're the threads that weave space and time together. By now, it should be clear that light years are more than numbers. They are cosmic rulers, history markers, and emotional instruments. But to truly understand their scale, we need to dive into some comparisons that bring them closer to human experience, even if only mentally. Imagine that the sun is a single tennis ball. At that scale, Earth would be a tiny pinhead orbiting a few meters away. The nearest star, Proxima Centauri, would be another tennis ball more than 4 kilometers away. This gives a small sense of the emptiness that light years create. Even the closest neighbor is separated by what would feel like an endless walk. And remember, Proxima Centauri is just the closest star. The Milky Way is a galaxy full of stars, all separated by distances vastly greater than that. Now, consider the Andromeda Galaxy, the nearest large galaxy. It is 2.5 million light-years away. If our Sun tennis ball and Earth pinhead were on a table in New York, Andromeda would be like another table halfway across the United States. Even at that scale, space would feel mostly empty. Galaxies themselves are enormous, but the distances between them are almost incomprehensible. That is why light years are so crucial. They allow us to handle numbers that no human scale could otherwise contain. Let's push further. The observable universe is about 93 billion light years across. That is mind-boggling. If we try to visualize it, imagine a map where 1 meter represents 1 light year. Suddenly, the Milky Way, which would be just a few centimeters on this map, sits on a continent-sized map that stretches across oceans of emptiness. And each dot on that map, each star, each galaxy, is a story billions of years in the making. Every light beam we see is a journey that began long before humans existed. The universe is literally a living museum of time, and light years are the labels that guide us through it. Here is an emotional perspective. When you look up at the night sky, every point of light is a traveler. That light has spent years, centuries, or even billions of years crossing the void to reach your eyes. Some of the stars you see may no longer exist. Some galaxies are showing themselves as they were billions of years ago. You are not seeing their present. You're seeing their past. Light years turn observation into time travel. Every glance into the sky is a glimpse into history. Light years also teach us patience and perspective. If humanity ever decides to explore other star systems, we must accept the scale. Even at speeds faster than any spacecraft we can currently build, traveling to nearby stars would take decades, centuries, or longer. Sending messages to distant galaxies is an exercise in cosmic patience. The nearest reply may arrive long after we, or even our descendants, are gone. Light years remind us that the universe operates on its own clock, not ours. Yet in this enormous scale, there is a profound beauty. The same distances that isolate us also connect us. Every atom in your body was formed in the heart of ancient stars. Those stars exploded long ago, their matter traveling across space before becoming part of planets, oceans, and life itself. You are literally made of ancient starlight. Light years are embedded in your very existence. The universe may be incomprehensible, but you are woven into it. To help audiences emotionally connect, here's a simple but powerful visualization. Imagine a photon of light leaving the surface of the sun. It takes over 8 minutes to reach Earth. That is fast, almost instant compared to cosmic distances, yet even that is measurable and finite. Now imagine a photon leaving a star in the Andromeda Galaxy. It begins its journey millions of years ago, possibly before humans existed. That light travels endlessly across space and finally reaches us, allowing our eyes and telescopes to catch a signal that has been in motion for eons. That journey is both lonely and miraculous. Light years quantify that miracle. Another striking example is the concept of galaxy collisions. Galaxies move slowly, yet over billions of years, they interact, merge, and reshape the universe. The Milky Way and Andromeda will collide in about 4 billion years. Even at the speed of light, messages between them would take millions of years. Light years remind us that the universe is not instantaneous. It is patient, vast, and continuous. Cosmic events play out over time frames that dwarf human lifespans. Finally, consider cosmic voids. These are regions hundreds of millions of light years across where almost nothing exists. If you were placed there, The night sky would be nearly dark, with no visible galaxies. You would realize that the universe is mostly empty, and yet the empty space is just as important as the galaxies it surrounds. Light years are the measure of both presence and absence, the distances that separate and the connections that bind. So, what does all of this mean for humans? It means that our brains cannot fully grasp light years, and that is okay. Understanding them intellectually is already impressive. Feeling them emotionally is even more valuable. Light years show us that we are small, but significant. They show us that the universe is enormous, but observable. They show us that we are connected to the cosmos in ways both literal and poetic. They remind us that even the tiniest spark of life, even one fragile planet, matters in a universe that stretches further than we can ever imagine. In the end, light years are not just numbers. They are distances, they are time, they are history, and they are connection. They are the measure of awe, the ruler of wonder, and the ultimate reminder of how vast, beautiful, and humbling the universe truly is. When your audience hears about light years, they should not just think about numbers. They should feel the scale, the mystery, and the poetry of the cosmos. They should imagine standing on a tiny planet, looking up and realizing they're witnessing the echo of billions of years of cosmic history. Light years are not meant to be fully understood. They are meant to be experienced.